Hi ladies and gents, welcome to the next video in the playlist. So what is diabetes? So the fundamentals are it's basically about the regulation of blood sugar. So diabetes is an inability to regulate blood sugar as the body would like to. So it's a suboptimal regulation of blood sugar. So just like the body likes to regulate things like pH and temperature, once we start going outside of that range, either too high or too low, it does damage to the entire body. How it's regulated, basically our pancreas pumps out what's called a hormone called insulin. Insulin allows sugar to be transported from the blood into the cells and tissues for use as energy. And diabetes kind of manifests in different ways, which I'll get into in just a moment. But the consequences of suboptimal regulation are basically can be very severe. It all depends on how suboptimally we're regulating blood sugar. And I'll cover that in a separate slide in a moment. The most important thing on this slide is the abstraction. I think when we think about diabetes, we all think about it in terms of sugar at the moment, or at least everyone I've spoken to about it thinks of it in terms of sugar, which is true, but also sugar is a form of energy. It's our primary source of energy. So a suboptimal regulation of blood sugar can be rephrased and reframed and rethought about as a suboptimal ability to absorb and use energy. And I think it's important to think about it in this way, because this can really be used as a motivation to manage blood sugars more effectively, because we're effectively managing energy more effectively. And also for people without diabetes, it adds that extra layer of motivation to try and avoid getting diabetes, because when we abstract it and think about it in terms of sugar, it seems to have less, or at least to me, it's less impactful than thinking about it in terms of energy. No one wants to have an illness that fundamentally attacks and undermines our ability to absorb and use energy. So I think it's important to think about it in that way. Oh, I didn't realise that. Yeah, it's a stereotype. I don't know why that popped up so late. So what I mean by that is the word diabetes can be broken down, and it is broken down into several different types, but also within those types there's a lot of individual variation, so variation between people, even though they're categorized as type 1 or type 2, etc. So it's important to recognize the fact that there's kind of it's a spectrum problem, much like I think pretty much every other health problem that exists. How it manifests, so this is the types. So although there is a lot of individual variation, there are some commonalities between types. So type 1 is the least prevalent of these two main types. There are different types, so I'll go into that in a different video. But type 1 accounts for roughly 10% of people with diabetes. And this is due down to insulin quantity. So what happens is the immune system attacks the pancreas, kills off the cells that produce insulin, and without enough insulin, blood sugar tends to accumulate or does accumulate in the blood rather than getting into the cells and tissues for use as energy. And this accumulation and concentration of sugar in the blood is very damaging to the entire body. Type 2, which is the most prevalent, accounts for roughly 90% of people with diabetes. So if we hear about it talked about on the news, it's usually type 2 that they're referring to. It's down to the insulin quality, or the effectiveness of insulin. So they tend not to have any problem with quantity to begin with, at least. The problem is that the insulin isn't very effective. So the pancreas is producing that insulin, but it's not very effective in transporting the sugar from the blood into the cells and tissues. So this can be thought of as cell sensitivity or receptivity, or insulin resistance. Now the thing is, this forms a vicious cycle which eventually affects the quantity as well, because high blood sugars tends to kill off the cells that produce insulin. So if our regulation is suboptimal, then our cells are start to be killed off, which makes blood sugar regulation even more suboptimal, and forms this vicious cycle whereby our blood sugars get worse and worse. So type 2, that's basically why people with type 2 diabetes tend to be able to manage diabetes to begin with just things like diet and exercise, and then eventually move on to oral medication, and then eventually move on to insulin injections. I don't know why things keep popping up in random orders, but yeah, type 1 and type 2 are the main two types, although there are other different ones as well. Now the consequences of poor blood sugar control are pretty varied and vast. Let's see if I've got, yeah. So it damages the entire body, because the blood goes to the entire body. It especially damages areas towards the periphery of the circulatory system, so things like the eyes, things like the kidneys. Retinopathy, neuropathy, nephropathy, and hepatopathy are the kind of official names. Retinopathy is damage to the eyes, neuropathy, damage to the nerves, nephropathy, damage to the kidneys, and hepatopathy, damage to the liver. And we basically have increased risk of pretty much every illness under the sun, unfortunately. So heart attacks, strokes, dementia, Alzheimer's, various cancers. That said, although that is extremely negative, going back to what I said in the previous video about positive framing and trying to use this negative as motivation to live as healthy a life as possible, it's important to know that people with diabetes can live to have diabetes for 70 plus years. So it's all down to how much effort we put into managing blood sugars, as to whether we reduce the risk of getting all these things and hopefully not get them. And this is what I've dubbed the spectrum analysis. So I've got 3 pictures of this, and this is how I think about the types of diabetes, and kind of to try and include the individual variation rather than the kind of stereotypical types that we've got at the moment. So at the top there we've got the causes. Is it to do with genetics, environmental, lifestyle factors, or both? Usually both. Whereabouts do we lie? Everyone lies at a different point in this spectrum. How it manifests itself, is it something to do with an immune system response, an autoimmune response, or is it to do with the fact that our cells aren't receptive to insulin, aka insulin resistance, or is it both? Again, everyone will lie at some different point along the spectrum. This is the vicious cycle I just spoke about in a bit more of a visual representation, so it makes more sense. So the pancreatic beta cells are what produce insulin. The quantity is obviously from very little to enough or plenty. Amylin is something I didn't speak about. That's a hormone that helps regulate blood sugar as well. It's less talked about. Insulin is the main one that's really spoken about. Amylin helps to regulate blood sugar in 3 different ways. It increases satiety, so it increases our sense of fullness, which reduces the likelihood we're going to overeat. It slows the movement of food from our stomachs to our intestines, and therefore slows or reduces the spike of blood sugar after a meal. And the third one is it inhibits another hormone called glucagon, and glucagon's job is to break down glycogen in the liver and dump glucose or sugar into the blood. So with less amylin inhibiting glucagon, that means that the glucagon's more likely to dump sugar into the blood in quantities that it's not necessarily needed, and at times when it's not necessarily needed. So yeah, we've got the insulin and amylin production, both quantity and quality. I think this is reasonably self-explanatory, so I don't really need to go into too much detail, but an important point is hyperinsulinemia. So with type 2 diabetes, something I didn't speak about is that, to begin with, when the body recognises that our blood sugar is sort of ramping up beyond what it should, it starts overproducing insulin. So the insulin is less effective, but we're producing more and more of it, and this can lead to pancreatic beta cell burnout, which is another part of the vicious cycle. But importantly, hyperinsulinemia is actually one of the main things responsible for chronic inflammation, and chronic inflammation, as we'll see in the next picture, is responsible for pretty much all the illnesses that we know about. The only thing that I want to really point out here is the bit on the left as well. So we've got the rate of loss of the regulatory system, our ability to regulate blood sugar. With type 1 diabetes, it tends to be very rapid. With type 2 diabetes, it tends to be very gradual. Our ability to regain our regulatory system, with type 1 diabetes, the only research I've seen where where a biological entity is able to regain their ability to regulate blood sugar is in I think it was either a rat or a mice, and that was with lots and lots of repeated fasting, which I'm not sure is replicable in humans. But with type 2 diabetes, there is a good portion of people that are able to regain that regulatory system, so that's an important thing to note. And then of course the rate of regain, are we able to regain it slowly or rapidly, and that depends on A, whether we're able to regain it, and 2, what sort of measures we implement into our lives. Now with the chronic inflammation, there we go. Obviously, the lower the better, the higher the more cause of all these illnesses, and I'll let you read it. No point in me really reading it out, but obviously all these things affect our quality and length of life ultimately. And I try and think about things in terms of quality and length of life, because it really helps me to kind of de-abstract things, really make things a bit more concrete. But yeah, hopefully this was helpful to you. I kind of skipped through the pictures a bit quickly, so if you want to, just pause them and see what you think. And yeah, I hope this was helpful to you. Please do let me know what you think in the comment section below, and I hope to see you in the next video. Cheers.